All right, number 8, we want to determine the point estimate and margin of error. So just like number 7, we're going to add these two and divide by 2. So we're going to take 15 plus 27 and divide by 2. That's going to give me my point estimate. 3242 divided by 2 gives me 21. And then if I just 21 minus 15, that will give us 6. So I'm just using the edge, but you can do 27 minus 15 and divide that by 2 as well. Gives you 12 and divide that by 2 gives you 6. Number 9, 6 parts. Simple random sample size n is drawn from a population that is normally distributed. Sample mean x bar is found to be 109. Sample standard deviation s is found to be 10. We're going to construct a 98% confidence interval about the mean if the sample size is 22, and then 17, and then we're going to go from there. So the formula is which I'm going to do it in StatCrunch, but just showing the formula. So just remember the t value, if we're doing a confidence interval, is going to be equal to x bar minus the mean over s divided by square root of n. And working backwards, you would multiply that and then add the mean. So you get that the population mean, interval around it, is equal to the t alpha over 2 times the s over square root of n, should be plus or minus that, plus the sample mean. So the sample mean plus this and minus that, that's the formula. So we're going to let StatCrunch do this. So get more help, StatCrunch. We are going to go to Stat, calculators, no, not calculators, T-Stat, one sample with summary. So the sample mean 109, sample standard deviation is 10, sample size for the first one is 22, and then we want a confidence interval, 98%, so we're going to change this to 98, and then that's it. We get our lower limit and upper limit. We want to round to 1 decimal place, so 103.6 and 114.4. 103.6 and 114.4. Alright, so now when we do that one, I'm going to go to options and I'm going to just edit. So that allows me to keep the same information, which is what I want, and I just want to change the sample size to 17. So sample size is now going to be 17. Still 98 degrees, sorry, 98% confidence, level of confidence. And we get 102.7. And we get 115.3 when rounded. Alright, so now we're going to do a 95% confidence. So I'm going to do edit again. 109, everything is still the same. It's 22 was my sample size. Level of confidence It's going to be 95. And then compute. We get 104.6. I guess it's not asking that yet, so they got a middle part, but I have that right here. So it says, how does decreasing the sample size affect the margin of error? So sample size was 22, and then it went down to 17. So the margin of error got bigger. Decreasing the sample size means I'm gonna have more error. So as the sample size decreases, margin of error decreases. Sample size went down, the confidence got bigger, so there's more error. Sample size decreases, error increases. Okay. And then we got this confidence interval, which is going to be 104.6 and 113.4. And then part 5, it says compare the results obtained in A. How does decreasing the level of confidence affect the margin of error? So if we look at this interval, 103 to 114, and this was 104 to 113. So less confident gives me a smaller error. Big confidence, this interval is 103 to 114. Less confident, 95, shrinks the interval. So less, decreasing the confidence decreases the error. So as the level of confidence decreases, the sample size, the size of the interval decreases, yes. Okay, so A. And then could we have computed the confidence intervals in parts A through C if the population had not been normally distributed? No, we could not, because the sample size are not big enough. No, population needs to be normal. We could not have done it. Okay, yeah.